Hello everyone, my name is wenhaoc4. So far, I know we have learned some basic knowledge about the BGP routing. And in this presentation, we are aimed to have a deeper look into BGP routing, and I would like to talk something about this protocol in more detail. The whole part can be divided into 5 parts. In first part, I would like to do a recap for everyone why we need BGP and why BGP is critical to the internet. And then we will have a BGP overview and get to know more about the detail of its protocol. And we will get to know what's the BGP message type and what's the BGP attribute type. And after that, we would like to show how BGP choose the route. Okay, so let's show why BGP is quite important to the current network in the world. As we know, the autonomous system is a network of groups of routers which is run by organizations. And each autonomous system might include thousands of routers and different AS need to exchange the routing information. However, each AS could use a different IGP routing protocol with a different metric. So AS don't trust each other, and there is no enforced hierarchy between AS connections. Also, currently, Internet route table can now have about 250,000 routes, so such scalability is quite large. So we need a solution. We talk about IGP as interior gateway protocol, and there is another class of protocol called exterior gateway protocol. There are only 2 EGP in existence. The one is original EGP protocol, which is classical and is hierarchy in network. And the new one is called Border Gateway Protocol, which is BGP. And BGP is optimized for scalability instead of convergence time. So BGP actually converges slower than most IGPs. It may take minutes or tens of minutes to converge, but it can handle 250,000 routes. BGP has advanced filtering features, which can filter based on not only the IP address, but also the autonomous system. And BGP uses AS path list to avoid loops. It keeps tracking which autonomous system a path goes through. And what's more, it uses a number of AS hops as universal metric. So let's have an overview on BGP. There are many claims saying that BGP is a simple protocol. So why it is simple? The first reason is that it uses TCP port 179 for a reliable router-to-router communication. So TCP handles a reliable delivery and makes each message get to the destination router only once. There are only 4 message types: open, keep alive, update, and notification. That's it. Also, there are only 6 protocol states. There are also many filtering or prioritization options, but each one is technically simple. The first message type is open. The open message goes through TCP socket. So firstly, you build a TCP socket between routers. You got TCP socket open, and you send a BGP message open through the socket. The open message includes the BGP version, send autonomous system number, and the hold time, which is how long the BGP session can stay up if it doesn't receive the message. If BGP session doesn't receive any message in hold time, it will be considered as failure and then be shut down. Also, BGP identifier and optional parameters are contained in open message. Then the second type, keep alive. In this message, I may say, hey, I'm still alive, so let's keep this BGP session open. Meanwhile, it will send 1/3 the whole time. Well, this is the third message type, update. This is a message that transmits the network layer reachability information. Now that phrase, network layer reachability information, NLRI, used too scary. It's big and complex phrase, but it's just a complicated way of saying the IP prefix and length. And the message also includes path attributes which contains the information about each route, and we will talk more about it in detail in the next slide. And it might include some withdrawn routes like 11.2 and 10.4 and a .0/24 is no longer reachable via this path. So it is deleted from your table. And that's the BGP type 3 update. And you know that that's the most complicated BGP message there is. It's the routing information and what prefix you can reach and the attributes that describe that have information about each route. And the last message type is notification. In this message, we terminate or reject a BGP connection. And we can also include error message, like BGP version not supported. Okay, then let's go on the 6 BGP neighbor states. By states, I mean you have BGP process in your router, and these are the states that the process can be. The first is idle. BGP process just started up or BGP error just occurred and trying to do anything in the idle state. The connect state, that's when you initiate a TCP socket connection request to a neighbor. Active, that's when you repeatedly attempt to connect to neighbor via TCP socket. Open sent, that's when you establish your TCP socket and send the open message and you are waiting for a response. Open confirm, you establish the TCP socket to the neighbor, you sent your open message, you got an open response and an open message back. And then the established, that means you have received a keep alive or update message, and then you are exchanging data. Okay, then let me talk more details about the BGP attribute type. The graph in the right perfectly shows the composition of BGP attributes. All these attributes are included in BGP attributes. Each network layer reachability information, each advertised route has attributes. There are different categories of attributes. A well-known mandatory attribute is an attribute that have to be included with every BGP update. A well-known discretionary attribute is an attribute that every router understands, so it's well known, but it doesn't need to be included in every update. And optional attributes may not be understood by all BGP speaking routers, and it can be divided into two parts. Here, the transitive means that if you don't understand, you have to pass it on in the updates when you send them out to a neighbor. However, non-transitive means that if you don't understand, you just drop it, you ignore it, and you don't pass it on. So what's well-known mandatory attributes? The first one is origin. This is something that helps you understand the believability of the information with BGP. The most believable route inside BGP is a route that is originally learned from IGP. And EGP is the next type of origin. And that's a route is originally learned from exterior gateway protocol, which is a precursor of BGP. And the incomplete route, this is a route distributed from another protocol. And then the AS path. This is a list of AS that the route has passed through. For example, in the right graph, the message is transmitted from AS0 to AS3 via AS1 and AS2. and the corresponding AS is recorded in the AS list. And then next hop. This attribute is used for the IP address to forward packets to. And then we'll talk something about the well-known discretionary attributes. There are two elements. The first one is the local preference. It is a number used for route prioritization. And usually we set the default as 100. And for this number, the higher the better. And second one is atomic aggregate. This is used when the route was summarized. And then talk something about the optional attributes. For the optional transitive attributes, the first one is the aggregator. If the route is summarized, then you have to put this in well-known discretionary attribute atomic aggregator. But if you want, you can also put an aggregator attribute in the update, which identifies the router and autonomous system that summarize the route. And that can be helpful for people debugging if you are doing incorrect summarization. And the community is like a message, and you can send communities in the updates and tells, and you can configure routers to listen to particular communities. For example, one thing that's commonly done is you can send a community which sets a local preference to 80. And then on the other side of an ISP connection, the ISP might be configured to say, hey, if I receive the particular community, and a community is really just a number when it comes down to it. If I receive the community 26, then I will set the local preference to be 80 on any routes that I receive there. So communities are like messages that they do filtering. And for the optional non-transitive attributes, the first one is the multi-exit discriminator, which supplies a metric that allows comparison between and multiple paths between the same two AS, and also the original originator ID and the cluster list are used by router reflectors. Okay, then let me talk something about how we use the BGP to select the route. There are many parameters. The first one is the weight, locally significant Cisco-specific parameter that a router can set when receiving updates. The higher, the better. And second one is the local preference, which is preferred. Also, for the number, it is the higher, the better. And third, local path originated from IGP is preferred. And the fourth, which means shortest AS path length is preferred. And the next one, fifth, IGP is preferred to EGP, and EGP is preferred to incomplete information. And sixth, which means within the same autonomous system, lowest multi-exit discriminator is preferred. The seventh, it means the eBGP paths are preferred over iBGP paths. And the eighth, it shows the lowest IGP metric is preferred to the next hop IP address. And the ninth, it shows that given the BGP multipath, the minimum one is preferred. And for the 10th, it shows that the lowest router ID is preferred. Okay, then I will give two examples. In the first one, we can find the two addresses are same, and they also use the same origin IGP. But in this example, the left part, we can find the AS hop, the number of AS hops are just 2, and in the right part it is 3. So given these parameters, we will choose the root in the left. And in the second example, we can find both routes have the AS path as 2, AS path length as 2. But in the right example, we can find the next hop as 10.1.3.3. It's which is a smaller number about the router ID. So we will choose the right example in the we will choose the right one in the second example. Okay, then I will talk something about the BGP route advertisement rules. It only advertises the BGP routes that you prefer. So if you learn the route from the eBGP, it only advertises to all pairs, like both eBGP and iBGP. But if you learn the route from iBGP, it will just advertise to its eBGP pairs only. And then I will just show a simple example. In this graph, a message wants to transmit from AS3 to AS1. We can find firstly, this router learns the information from eBGP, and then it advertises to its iBGP pairs. After that, this router will advertise the information learned from the iBGP to its eBGP pair in AS1. And in AS3, here we can find the router will never advertise the information learned from its iBGP pair. Well, I think here it can just help prevent the loopback inside the AS, and also the loopback between AS can be prevented by the AS path list. Okay, so this is my whole presentation, and I hope my video can help everyone get to know BGP better, and thank you.